Hi student, this video is about analysis of function for rational function. In this video, I will show you how to find number 1 x and y-intercept, number 2 vertical and horizontal asymptote and its analysis. Vertical asymptotes actually refer to y-axis and horizontal asymptote refer to x-axis. For this function, we will find a new vertical and horizontal asymptote. And then number 3, we want to find interval where fx is increasing or decreasing. It's actually based on sign of f prime. So based on sign of f prime x. And then number 4, concavity. Number 5, inflection point. And number 6, we need to sketch a graph of rational function. So we have two type of graph. Either number 1, so the graph in first and third quadrant, and number 2, the graph is at second and fourth quadrant. So for the first example, we have fx equal to 3x minus 6 divided by x plus 2. So the first analysis is how to find x and y-intercept. So x-intercept, we just need to set y equal to 0. So our y is fx. So 0 equal to 3x minus 6 divided by x plus 2. And then solve. Okay, x plus 2 times 0 is equal to 0. So 3x minus 6 equal to 0. 3x equal to 6 or x equal to 2. This is x-intercept. And then we want to find y-intercept. Y-intercept. Just set x equal to 0. So we have y equal to 0 minus 6 over 0 plus 2 equal to negative 6 over 2 equal to negative 3. Okay, this is x and y intercept. Okay, number 2, we want to find vertical and horizontal asymptote and its analysis. So vertical asymptote, okay, vertical asymptote based on function at denominator. So denominator we have x plus 2. So x plus 2 equal to 0. So x equal to negative 2. And then its analysis. Okay, we based on limit. So we have limit x approaches to, we have value of x equal to negative 2. And then from right, we need to check from right and from left. So from right, and then we have function 3x minus 6 over x plus 2. The answer is either positive or negative infinity. So how to determine the sign? Okay, if we have a real number line, negative 2 here, and negative 1, negative 3. So this is from right, from left of negative 2. So if from right, you can choose one value that is greater than negative 2 but approaches to negative 2. Maybe you can choose x equal to negative 1.9. Okay, and then you substitute at numerator and denominator. If you substitute negative 1.9 at numerator, you get negative sign, and then minus 6 equal to negative sign. Divide by, and then if you substitute at denominator, we get negative 1.9 plus 2. We get positive sign. So negative divided by positive equal to negative sign. So we get negative infinity. So another one, if we have limit x approaches to -2 from left, function 3x minus 6 over x plus 2. Okay, this is -2 from left. You can choose one value that is less than -2 but approaches to -2. Maybe -2.2. And then you substitute at numerator. The value is negative sign, and denominator you get negative sign also. So negative divided by negative equal to positive. So final answer equal to positive infinity. This is analysis for vertical asymptote. Next is horizontal asymptote. Okay, horizontal asymptote actually based on limit x approaches to positive and negative infinity. So limit x approaches to positive infinity, and then function 3x minus 6 over x plus 2. If you substitute, you get infinity over infinity. So to solve this, you can choose one term at numerator with highest power of x, that is 3x, and then we can choose one term at denominator with highest power of x, that is x. So equal to limit x approaches to positive infinity 3x over x, and then simplify, we get limit x approaches to positive infinity 3 equal to 3, and then we have limit x approaches to negative infinity 3x minus 6 over x plus 2, and if you substitute, we get infinity over infinity. So equal to limit x approaches to negative infinity 3x over x equal to limit x approaches to negative infinity 3 equal to 3. So we get from left and from right the same value, so we can make conclusion here. Horizontal asymptote y equal to 3. Okay, next number 3, increasing or decreasing. So increasing and decreasing is really based on first derivative. So we have function fx equal to 3x minus 6 divided by x plus 2. So f prime x equal to x plus 2 times 3x minus 6 prime minus 3x minus 6 times x plus 2 prime divided by x plus 2 square. So equal to x plus 2 times 3 minus 3x minus 6 times 1 over x plus 2 square. So and then we expand numerator, we get 3x. So 3x plus 6 minus 3x plus 6 over x plus 2 square. And then you can cancel out 3x, we get 12 over x plus 2 square. Okay, we need to draw a table. So our interval actually based on value x plus 2 at denominator. Since our function is in fraction, so x plus 2 must not equal to 0. X must not equal to negative 2. So if x equal to negative 2, we get 12 over 0 mean undefined. So our interval is based on value negative 2. So if we have a real number line negative 2, so we have two interval here. The first one start from negative infinity, negative 2, and the second one start from negative 2, positive infinity. So for the first column, we have interval. Second column, test value. And third column, sine of f prime x equal to 12 over x plus 2 square. So the first interval, negative infinity, negative 2. So test value, we can choose x equal to negative 3. Means the value of x within this interval, not included negative infinity and negative 2. And then sine of f prime x, just substitute negative 3 into f prime. So numerator is 12, means positive. Divide by denominator, negative 3 plus 2, but we have square here, means denominator is always positive, equal to positive sign. And then second interval, we have negative 2 to positive infinity. We can choose x equal to 0, and numerator we get positive, denominator is also positive, equal to positive sign. So based on sine of f prime, since the first interval is positive, second interval is positive, means there is no extremum. No extremum means no minimum point and no maximum point. So we can make conclusion here. Fx increasing in the interval negative infinity, negative 2 union negative 2, positive infinity. Okay, next number 4. It's about concavity. Okay, concavity is based on second derivative. So first derivative, we have f prime x equal to 12 over x plus 2 square, or we can write as 12 times x plus 2 power negative 2. And then differentiate one more time. F double prime x equal to negative 24 x plus 2 power negative 1 time 1 here equal to negative 24 over x plus 1. So to form an interval, it's actually based on value of x at denominator. So we have x plus 2 here. X plus 2 must not equal to 0, so x must not equal to negative 2. So based on real number line, so we have two interval here. The first interval start from negative infinity, negative 2. Second interval start from negative 2, positive infinity. So the first column is interval. second column test value, third column sine of f double prime x equal to negative 24 over x plus 2, and last column is conclusion. So the first interval, negative infinity, negative 2. Test value, you can choose x equal to negative 3. And then substitute into f double prime. At numerator, we have negative sign divided by denominator. Negative 3 plus 2 mean negative, equal to positive sign. Conclusion is concave up. Okay, next interval. We have negative 2, positive infinity, and then test value, we can choose x equal to 0, and then substitute, we have negative over positive equal to negative sign, means concave down. Okay, number 5 is inflection point. Okay, inflection point, actually the value of x based on value of x f double prime, based on this value. So we have x equal to negative 2. Inflection point means we want to find the value of x and y. So x equal to negative 2. So now we want to find the value of y. So we want to find f, we have fx equal to 3x minus 6 over x plus 2. So f negative 2, just substitute negative 2 into original function. So we get 3 times negative 2 minus 6 over negative 2 plus 2. So denominator we get equal to 0, mean undefined. So you can make conclusion here, no inflection point. And lastly, number 6, how to plot a graph or how to sketch a graph. Okay, the first information that we have is x and y-intercept. So x intercept, so x equal to 2, y-intercept, we have y equal to negative 3, and then the information is about asymptote. So vertical asymptote, x equal to 2, and horizontal asymptote y equal to, vertical negative 2, horizontal y equal to 3. And then to plot graph, x and y axis, and then x and y intercept. X intercept equal to 2, 1, 2. So this is x intercept, and then y intercept, we have negative 3 here. And then vertical asymptote x equal to negative 2. We have new asymptote. Before this, for original function, we have vertical asymptote x equal to 0, means y axis. This is -2. So x equal to -2 is vertical asymptote. And then y equal to 3. It's our new y equal to 3 horizontal asymptote. So firstly, you can plot based on x and y intercept. So we have x and y intercept here at fourth quadrant. So the fourth quadrant is paired with second quadrant here. This is how our graph look like. Okay, that's all. Thank you.